All right, everybody. So let me tell you what I've been doing so far, and perhaps if you're going through the videos, what you've seen so far. I made a video for review purposes to talk about what exponents are. It's not completely exhaustive. It's not every kind of example that you might see, but it's at least hopefully triggered your thinking on it. Okay. And then I talk about what negative exponents are, same thing. Hoping to get the basic idea across if you haven't seen this in a while. And then now I want to talk about what graphing is. And of all the things that there are to review, this might be the hardest one. Okay? All right, so it's I guess what I want to do then, since my key concern or the question that I'm thinking about when I'm doing this is it even possible to review graphing in one video? I don't feel like I could get very much done in, say, 20 minutes, but I think I can get enough done just to focus on you understanding what graphing is about, what it means, what it involves, and then you could take that in your own direction, all right, and ask for help as you need it from there. Okay, so we're not going to learn everything. I mean, we'll never learn everything anyway, but I'll try to get you to get the basic idea as much as you can to empower you to do whatever you need to do. So, all right, let's talk about two things. First, there is an equation. In our case, it will probably be a function, but something like this, something where you plug x in and you get the y back out, all right? So we're going to have something like that. Plug the x in, get the y back out. Fairly simple as far as how that works. And then I want to get the graph of that, which is just like another side of the coin. The graph is not like it's necessarily some completely different thing than the equation. It's just another way to look at it, all right? It's every point that satisfies the equation. And I'll tell you what I mean by a point and satisfying the equation here in a minute. So suppose that I want to take an equation and draw the graph, and the graph is just every point that satisfies the equation. And I think the most natural approach to that is to make a table, okay? Like if somebody didn't know anything about graphs and had no idea even where to get started, then this is what I would show them. It's not the exhaustive approach to drawing graphs and understanding graphs and so on, but I mean, if we got to start here if we're going to get anywhere else. So look what I did. If a graph is just every point that satisfies the equation, and if the equation is plug x in and get y back out, then yeah, maybe we'll make a table and we'll get some points, and maybe there's some kind of pattern to those points. All right, I guess that's the real question, is there a visual pattern to those numbers? Okay, so all right, what I did is I took just a array of numbers here, and we can always argue about the numbers we choose. Why did I choose -2? Why not -3? Here I went over to 2. I could have kept going. Maybe I could have gotten to 5. Well, we'll never get anywhere, right? We'll just have to take some numbers and look at them and see if there's a pattern in those, and then extrapolate from there. That's probably the best we can do. So let's not argue a whole lot, at least now, about the numbers. But here, I've got an array of numbers. I've got some negative numbers. I went through 0. I've got some positive numbers. It kind of looks like I've got a little bit of everything. Okay? So, all right, what I did here is I took those x's and I plugged them in here, and then these are the y's that I get. All right? So I did all the math there, and then I plotted those points, meaning, like, so for example, this point right here, see that one? That has an x coordinate of -2 and a y coordinate of -8. And what that means is that on the graph, to get to that point, you go left 2 spaces and then you go down 8 spaces. Okay? That's what that is. And same thing with all the others. This second point is left 1 and down 6. So I plotted all those. Is there a pattern to it? Does it look like these dots here are completely random, scattered around, no pattern at all? Or does it look like something? It's like, well, when you look at it, you probably think that, yeah, those points, there's no coincidence there. They look like they all lie along a line. okay? And that's true. I mean, if I were to have more points, it would just confirm this pattern that I already see. All right, so the graph then, the graph is not these points. The graph is this total pattern that we have, okay? So let's see, I'm gonna try to do this. I wanna get it neat. I'm probably taking too much time. There we go. Okay, something like that. That looks a little sloppy, but you get the idea. Okay. All right. So there we have it. That is what I think that all the points would look like if I could graph them. Okay. So the graph is every point that satisfies the equation. When I did this, I had 5 points, but I think all the others would be consistent with the pattern I see on top of that, which is this line. And anyway, that's what the graph is. Okay. Now, let me clean it up a little bit. Maybe you can tell how much this bothers me. That I did not draw it really neat. But oh well. Okay. All right. Now, so that's the basic idea. Okay, that's the most natural thing to start with, I think. So here's some strategies that we might get from this point. Because from here, the only question would be, well, how do we improve this? Because this is a little bit of an act of faith, what I have there. I don't really know that the next point on this graph is going to be out there. See, I don't really know that. It's an act of faith. Until I plug in, what's that number? It looks like it might be 4 or 5. Until I plug that in and plot it and confirm that it's on the line, I don't really know. Okay, if I'm just looking at that equation all by itself and I don't know anything else about it. So yeah, we don't know if it does it take off in some other direction at some point, etc. There's some act of faith when we draw a graph sometimes. Okay, so here's how we could improve it from here. Is we could say, well, we can make a table and we can plot lots of points. Could you gather that the more points I have, the more densely it's going to fill in this picture and go past what I have and be an improvement on it. Okay, so yeah, the more points that we have on our table, the more accurate the picture is going to be. Another strategy for graphing is, what if you knew something about the shape in advance? As a matter of fact, any equation like this is going to be a straight line when you graph it. So, of course, if you know what the shape is supposed to be based on the equation, then that makes drawing the graph all that much easier. Okay? It turns out certain equations have certain kinds of shapes of graphs. And if I knew that this was a line to start with, how many points would I need on my table to draw it perfectly? You can draw a line with just 2 points. Okay? So the second strategy is, the more you know about what the shape is supposed to be, the easier it's going to be to figure out exactly what the graph looks like. Okay? Because from there, you might just plot a few key points. And then the third thing is, get someone or something to draw the graph for you. So, okay, yeah, I mean, that's not off limits. I mean, we have graphing calculators and things like that. If you need to know what a graph looked like, you could use that. Okay, it's nothing wrong with it. The only thing I want to caution against is, if you're a STEM major, if you're doing something that involves you really knowing some math and understanding what you're doing, I don't want you to just use a graphing calculator, okay? I would be a little nervous if you were a STEM major, if you were really supposed to know something about math, and you used a graphing calculator, but you had no idea what the graph really meant or what it told you. That would make me nervous. So, although this third strategy is important, and we should know how to use graphing calculators and technology like that, it's not the only thing that I want to emphasize for right now. I need you to know how to get by with the first 2 strategies as much as you can, alright? Alright, so now a caveat for 1 and 2, a big and open question is, which points do you choose and how many points do you choose? When I did this first example, I said these are the points I'm choosing. I could have chosen ones that are slightly different. I could have chosen more points, right? And that's always going to be an open question depending on how much you know already, okay? All right. Yes. So sure. I mean, there could be some variation and differences of opinion on those two issues. All right. So let's do this. I want to go through the strategies, and this third strategy says get someone or something to draw the graph for you. When I wrote this, I really meant that we should get something to do it. Not that you would really ask somebody else, but something else. So here we can do this. Say I want to use a graphing calculator or similar tool to graph this one. To graph this one, an equation like this, with just a table is a little bit tedious, okay? I mean, it might take quite a few points to nail down the shape, but you could try it, all right? If you want to, you could try to graph this one with just a big table, and the more points you choose, then the shape's going to come together, all right? But remember, I said that, I mean, you should at least know about graphing calculators and so on. So I'm going to go to this Desmos graphing calculator, and this is just one of many things you could use, okay? And I'll put this in here and we'll see what it looks like. Okay, y is equal to x to the third power minus 7x squared and then plus x. Okay, so there's my equation, and let's see what the graph looks like. I typed it in, and I might need to zoom out to get a right amount of detail, but there I'm seeing a picture emerge. All right, I see something that takes shape. So there, like if I need to know this graph, I'm now looking at it. Now, as far as me wanting you to understand what you're looking at, then there's points on it. You see this point right here? It says that in this equation and on this graph, it's true that if the x is 7.233, the y is 19.423. All right, there's probably some rounding in those numbers, but if we took that x and that y and plugged them into the equation, it would work, okay? So it means the same thing as what? It means the same thing as this first graph does, as far as how you interpret what the points on it are. Okay, so now that one's easy. Yeah, get a graphing calculator draw it for you. That's not hard to do. Okay, I wanted to draw your attention to it, tell you that it's okay. Now, I think from here, it would be good to know some basic shapes, because like I said, I'm not comfortable and I'm a little nervous having you rely exclusively on a graphing calculator and be clueless to whatever it's telling you, okay? So, for example, any equation that looks like y equals mx plus b, y equals a number times x plus another number is going to be a line. That first example I showed you was this one right here. And anything like that, anything that says y equals a number times x plus another number will be a line. And so that would make it easy to graph if you already know it's supposed to be a line. Okay, so it might be good to recognize that one. You know, y equals ax squared plus bx plus c, where a, b, and c are constants, they're fixed numbers. That will be a parabola. It will look like either this or that. And so again, like, I'm going into it knowing what the shape is supposed to be. All right, like for example this one. We'll talk about this one in a minute. And there's so many more, like these absolute value, y equals the absolute value of mx plus b, where m and b are again constant. That's going to be a v shape of some kind. But again, you know the shape. Now, it might not be the case that you've ever heard of a parabola or absolute value. For the purpose of this video, I'm just telling you that certain equations have graphs that take on certain shapes. And if you can figure that much out about it, then at least you know what the graph is supposed to look like. Okay? Now, there's many more shapes and so on. There's too many to cover in one video. All right, but what I'm trying to do is have you get a feel for graphing rather than tell you everything that you need to know about it. But let's do this. In order to talk about strategies a little bit, I said you can make a table with lots of points, and that's kind of what I did on this first one. I was pretending I didn't know it was a line, and I just made a table and I plotted some points, and they came together and they looked like a line. Okay. And then I said, well, you could use a graphing calculator, and sure, then I showed you that. But what if, like, let's try to like actually do this where, suppose you knew something. Suppose I give you a hint about the shape of the graph. Could you plot a few key points to figure out what it's supposed to look like? Okay. Now, let's do that with this example down here. can you graph this one, y equals negative x squared plus 4x plus 7, given that I tell you the vertex point is at 2, okay? Now, real quick, let me tell you about the vertex point and about this equation. What I'm telling you when I ask you to graph this and I give you the hint is I'm saying, well, this type of equation is a parabola, meaning it looks like a right side up or upside down U. In addition to that, of all the points on a parabola, one called the vertex stands out. The vertex is this point at the very bottom or this point at the top. Okay? So when let's say for the purpose of this video, for me to walk you through a strategic way to graph something by yourself, I'm saying this right here looks like this or this, and that vertex point, that point that's either like right in the middle of it, at the bottom or the top, is at 2, okay? All right, could you put the rest of that graph together for me with all that information? Like, could you use what I've told you so far with the fact that, well, you know, a table and the points on the table have some role to play in the graph, and the fact that I've given you a hint about this one, could you use all that to figure it out? Okay, so the way I would go about it is I would plot this point, and then I would plot some on each side of it. That seems like it would complete the picture, because if the vertex is this point that's either right in the middle at the bottom or the top, then you just got to figure out what the sides look like, because you know what the shape looks like outside of that. So what you might do is make a table like this, the vertex being this point in the middle. Okay, so we know what the middle, we know where the middle is, and I'll choose some on the left. So the vertex is at 2, so what's left of 2, you know, on the number line? 0 and 1, and some points to the right. What's right of 2? 3 and 4. And from there, I plugged in the x's and I calculated the y's, and I get a bunch of points. Okay, and remember, I want to see if there's a visual pattern to the points, so I plotted 0 for x, 7 for y. That's this one right here. I plotted 1 for x and 10 for y, and so on. So I plotted all these points on a graph, and sure enough, they do take on that pattern that I told you we would expect, either a right side up or upside down U. Okay, so yes, there is a visual pattern, and I believe that the rest of the points would lie somewhere on this curve like this. Okay, you know, I believe that if I could identify what this point was, it would fit in that equation. That if I could take the x coordinate and plug it in, I would get the y coordinate back out. All right. Okay, so yeah, we might, when we graph, we might do something like that. We might use some foreknowledge about what the graph is supposed to look like, in addition to some points to fill in the other details. Okay, so we might do something like that. All right, so let's talk about one more thing, and only one more thing, because I can't tell you everything about graphing. I'm just trying to get your interest in thinking in the right direction with it. The domain of a function and its graph. So as far as what the domain of a function is, remember how in the beginning of this video I said that when we talk about graphing, we're probably going to be dealing with a function. And the way that works is that the x goes in and you get the y back out. Okay? That amounts to a bunch of points. And visually, the points on graph paper make a pattern. And that's what the graph is. Okay? So, I guess with this one, it's true that when you plug the x in and you get the y back out, that it does work like that. But with this formula being the way it is, I can't plug just any number I want in. Like, I can't put negative numbers into that. Okay? There's something called a domain of this function. The domain is what you can plug into it. So I can only plug in x being greater than or equal to 0, meaning I can't take the root of a negative number, and I can't get a number from that I could plot on a graph. Okay? So in this function, only positive numbers are allowed to be plugged in. Negative numbers are off limits. 0 is okay, and anything positive. okay? Negative numbers will not calculate in this function, at least in a way that graphing them would make sense for us, okay? All right, so yeah, there's a restriction here. So in that case, I'm not going to plug in just any number I want if I was to make a table. I would only plug in the numbers that were possible and that made sense. Okay. All right, so when I make a table for this one, I'm going to choose anything but negatives. So I might start 0 and plug that in, and anything bigger than that. 149. I chose 149. Why did I choose 149? There's always a little bit of choice here if you make your table. Well, I saw that this was a square root, and me doing this here right now, I thought it'd be nice to take numbers that actually are perfect squares. Okay, so here goes. I've got my domain, my restriction is expressed. This formula is such that you can only plug in positive numbers or 0 into it. So I started with 0, then I've got positive numbers going out that way. Okay, so 0 plugs in, square root of 0 is 0, 1, square root of 1 is 1, 4, square root of 4 is 2, 9, square root of 9 is 3. I could keep going. Maybe the next sensible number would be 16 and so on. But this is probably enough. Let's see. Is there a pattern if I plot these points? Here's the first point, 0 for x, 0 for y. The second point, 1 for x, 1 for y. 4, 2, 9, 3, and so on. And again, it does look like there's a pattern. It doesn't look random. If I had any doubt, I could squeeze some more points in here, and I'd probably see that they all fall in line with regards to a pattern like this. Okay? All right, yeah, something like that. That's definitely what it looks like. Now notice, though, I started by telling you that this one has a restriction on the domain. I can't plug just anything I want into that formula. That's the way that it is. Negatives are off limits. I made my table according to that. I plotted those points, and then I noticed from there that why didn't you see when I drew the pattern on top of these points? Okay, the points suggest some visual pattern. The graph is that overall pattern and all the points that go along with it. Why didn't I continue it like off this direction? It kind of looks like it might sort of elbow down there. Why didn't I draw it down here? Why didn't I go past that point? Well, I mean, again, I'm going into this knowing something about it. And what I told you this time is that in this, only x can be positive. All right, negatives aren't allowed. So that means that not only are there no points over here, but there's no graph either, because that's what the graph is made from. Over here are where the negative numbers for x are. There can't be any points over there. Maybe it kind of looks like it's going that direction, but there can't be anything over there because those numbers won't calculate in that original function. Okay, so all right, I deliberately have it stop here. I didn't draw any past that original point of 0 and 0. It will not exist left of that. Okay, so that is definitely a crash course on graphing. There's way more to say about it, but these are some basic considerations, some basic things that you should know, and then hopefully from there you could take it in whatever direction you need it to.